All right, so we're back. So this says here, I can distribute, I should say, or multiply across a polynomial. So the exponents change when multiplying with the same letter. What I mean by that is like a times a times a. If there's three a's, the exponent becomes 3, because that's a times a times a, and that's exactly what a cubed means. It means you multiplying a 3 times. So when I do this, 3x times 2x, first you do the coefficients. 3 times 2 becomes 6, and x times x, well, there's 2 x's, so that's x squared. It changes the exponent when there are multiples of that letter. So now we have a negative here, so you can imagine there's a plus in front of that. So a positive 3 times a negative 5, that's going to be negative 15, and an x times a y squared, those are not the same number, so, or sorry, they're not the same letter, so the exponent doesn't change. You just write them down. So 6x squared minus 15 xy squared. Now, if you like the box method, what you end up doing is you take the first one, you put it there, and then you take what's in the brackets and you put each of the terms in its own little box. So this is a term, this is a term, and this is a term. Make sure you take the sign in front. If there is no sign, then it's a positive. Nothing goes in here. So here you write 3 times 2, which is 6, and x times x, which is x squared. Here you write 3 times negative 5, which is negative 15, and x times y squared, which is xy squared. And this right here is your final answer. And you can see right there, 6x squared minus 15xy squared. So you still would need to write this out. Write out your signs in between. They're not multiplying, they're doing whatever adding or subtracting is in front of them. That's the box method. So you have to distribute to all terms in there. So this becomes 2 times 4, which is 8, and b times a, which I usually do it in alphabetical order, a, b. And you have 2 times 7, it's going to be positive 14, and b times b. B times b is b squared, because there's 2 of them. You're done. All right, now it gets a little bit more complicated when we have binomials. That means there's 2 terms. 2 terms, we're multiplying binomials. So you can use FOIL or box method, and you still might need to simplify your answer either way. So I will do the first one using FOIL, I will do the second one using box method, and the third one we'll do whatever you want. So if I do FOIL, FOIL means first, which means I multiply the 2 first terms. That's m times m, which is m squared. Then I do the outside terms. So they're kind of like the last terms. There we go. So we do m times 6, which is plus 6m. Then I go on the bottom just because it gets kind of crowded on the top. Now you do the inside terms. So we do negative 7 times m, that's negative 7m, and then you do the 2 last terms. That's going to be negative 7 times 6, so it's going to be negative 42. Now you want to look at this. You did all the multiplying out, but if you always do it in that same order, those 2 middle terms will be like terms, which means that they have the same letter with the same exponent. We don't have to worry about the numbers in front, but that's what we do the math with. So m squared, write it down, we don't change it, and it's 6 minus 7, which is going to be negative 1m, and the last term just stays to 42. Make sure you write down the m. Now if you don't want to write down the 1, I know some people really need to, but technically you really should write it this way. This would be the proper way. And the other thing that you should be doing is putting the exponent decreasing. So this is squared, and then it's to exponent 1, and then there isn't any letter there. So the biggest exponent down to a letter with no exponent, and this is just a numerical number right there. Okay, so now we'll do the box method. If you like the box method, nothing goes here. The first brackets, we write a term. Make sure you take the sign out in front. So if you want to put a plus, because there's a plus in front of there and that makes you feel better, go right ahead. 5x plus 4. Eat a term in its own box. And then you go ahead and multiply out. So 2 times 5 is 10. I always do I do sign, number, and then letter. X times x is x squared. 2 times 4 is 8, but don't forget there's an x in this term. Negative 5 times 5x, that's a negative times a positive, so it's going to be negative. 5 times 5 is 25, and we still have an x from this term. But the exponent doesn't change because there's no x in this term. And lastly, we have just the two numbers. One's a negative, one's a positive. So it's going to end up negative, and 5 times 4 is 20. And then make sure you don't write down any of the initial numbers. It's always these, or initial terms, it's always these ones that you've multiplied out. So I'll write them out. But if you want to take a shortcut, what you will notice is that these two diagonal terms will be like terms. So I always write them down together. So 10 x squared, and then you can write them in whatever order you want, plus 8x, but I always do the like terms, and then I do that last one that's just a number last. And then those two middle terms should be like. If you're doing the box method and you can simplify them and jump right to this step, you go ahead, but I'm not going to, so I have a positive 8 and a negative 25, or subtracting 25. So that means that one is bigger, so it's going to end up being a negative value. All right, and then it's going to be negative 17x minus 20. Okay, and there we are. Biggest exponent down, this is just a number. There's no more like terms, so that's finished. Now, this might not look like you're multiplying two binomials, but there is an exponent outside the bracket. So what that means is it means there's two of those things of everything that's in the bracket. So it's 3x minus 7 times 3x minus 7. It's the same thing twice, but that 2, exponent 2, applies to everything in the brackets. So I'm going to use the FOIL method. I'm going to multiply firsts, which is 9x squared, because 3 times 3 and x times x. Then I'm going to do my outsides, which is going to be 3x times negative 7. So 3 times 7 is 21, but only one of them is a negative, and I have the x from the first term. And negative 7 times 3x, that's going to be negative 21x. Oh, look at that. They're the same. And last but not least, negative 7 times negative 7. Negative times negative is positive. And then you have 49. So what you notice is those two middle terms are actually identical. So write down your first one. So this is going to be negative 42, because it's going to be 2 times of them, plus 49. And that's a perfect square. Because the 9 squared and 49 is a perfect square. And that's important for when we do factoring, which is the next page. Alright, so I can evaluate a polynomial by substituting a value in for a variable. Okay, so a value means a number, and a variable is a letter. So the dimensions of a school parking lot are 2x plus 7 by x plus 3. Essentially that means that there's a rectangle, and it has dimensions, which I know it's strange, but we have to get polynomials in there. The dimensions, like the length and the width, are actually binomials. So it says write a quadratic expression that it represents the area of the parking lot. Well, area is equal to length times width. And if we had let statements, we probably should write let the length be 2x plus 7. Okay, let the width be represented by x plus 3. I don't have room to say represented by. Either way, that makes sense to me. All right, so to find the area, I need to multiply those. So the length is 2x plus 7, and the width is x plus 3. And if I multiply those out, I'm going to get a quadratic. A quadratic means the maximum exponent is 2. So I'm going to go ahead and get the quadratic expression. So I'm going to multiply 2x times x, which is 2x squared, multiply 2x times 3, which is positive 6x, 7 times x, which is plus 7x, and 7 times 3, which is 21. And I still have to simplify because right here are some like terms that I can get together. So 6x plus 7x is plus 13x. Write down the 21, I haven't done anything. There is an expression that is a quadratic for the area. So right there, a quadratic that represents the area. Now it says, what is the length, width, and the area if x equals 5? So if I said, what are the dimensions here? I could use these. So length equals 2x plus 7. This just means I want to actually find the number. So if x happened to be 5, I would put in the 5, because x is equal to 5. And I do the math. 2 times 5 is 10, plus 7 is 17. But I should go back and think about this because this is a length, it's a measurement. It has a unit of meters. So the length is equal to 17 meters. The same idea with width. The width is represented by x plus 3, but x is equal to 5. So I substitute it in. That's the substitution. 5 plus 3 is 8, but that's a measurement in meters. So the width is equal to 8 meters. Now, there's two ways that you could get that. And you could actually just find the area by multiplying 8 times 17. Or, for fun, you could put it into here. So if I put in 2 times 5 squared plus 13x, x is 5, so I substitute it in, plus 21, I should get the same answer, is 8 times 17. So that should be 136 meters squared, because 8 times 7 is 56, 8 times 8 times 1 is 8, and that should be 13. So let's see if this works out to be the same. 5 times 5 is 25. You can do that in your calculator. And 25 times 2 is 50. I always think of that as quarters. Okay, 5 times 3 is 15. And then 5 times 1, I get 65, and then plus 21. So let's see. Now it's better if I do this vertically, but if I look at the ones, it's 1 plus 5 is 6, and 2 plus 6 is 8, and that's 136. Oh look, it's the same. And that makes sense because this quadratic came from multiplying these binomials. So it really doesn't matter if I multiply these numbers or if I put in 5 in here because they both came from the same spot. All right, I'm going to stop this, and the next video will be for page number 2.